We're going to go into the documentation directory, into a directory called EasyRSA, and run all these commands. And we're going to have to input all the data fields for our keys and our certificates. And then for each server, we're just going to run build key server and then the name of our server, and it spits out a server.key, a server.certificate for every server and every client. So we're going to end up with a bunch of key files and a bunch of certificate files. Well, what do we do with them? It's nice here that there's a little table that tells us where all these files go. Basically, the server is going to need the server key, the server certificate, a certificate authority certificate, and this Diffie-Hellman parameters file. All the clients are also going to need the certificate authority certificate, and then their own certificate, and then their own key. That may sound kind of complicated, but you can always come back to this table. And if you're familiar with how public key encryption works, the private key stays on the client. The certificate is, not secret. And the certificate is actually what gets sent to the server. And the server verifies that certificate against the certificate authority certificate. So you can kind of ignore all that and just follow the how-to. But just trust me that I've generated keys for every client, and they've all got these key files in the right place. So let me get back to my little config file. So that's what this is saying here. It's saying use this certificate authority file. You don't need this file on a client. That's why it's commented out. Here's my certificate, laptop.certificate. Here's my key, laptop.key. Honestly, I can't remember what this does. And this is kind of important. This directive here tells OpenVPN to create a route after the connection is made. And it's saying create a route to the remote host. This is a keyword that just puts in this IP address. This is a host route. We'll talk a little bit about net masks later, but since this is all 255s, this is a host route through our current net gateway. So why is that important? If I were to connect to my VPN, remember I'm using a tap device and run DHCP. When I run DHCP, it's going to tell me a gateway for my remote gateway. Well, once I have a gateway for the remote gateway, my other gateway has gotten wiped out. So how am I going to keep connecting to this IP address over the untrusted network? And let's run it, and maybe you can see more what I'm talking about. So I'm going to become root because OpenVPN needs to be able to be root to set up some things, but then it'll give up the root privileges. I'm just going to become root. Okay, and this is going to connect to my server over the internet. Okay, it looks good, like it's all connected. So let's look at what happened. I'm going to have a virtual tap device now. Well, actually I'm not, because it hasn't come up, but I have a virtual tap device, trust me. And I need to run DHCP on it in order to get it to show up into ifconfig. So let me become root again. Tap O. And so I just ran DHCP on my virtual tap device, and I got an address from my remote network. So let's look at the routes now. when I connected, it gave me this host route. This is that route line that was in the config file. So, okay, DHCP actually didn't overwrite my old default route. Right now I've got two default routes. So if I want to send all my internet traffic through my VPN, I'm just going to delete this route, which is the route that goes through our Wi-Fi. So I'm just going to delete this. .192.168.1.254. So now my default route goes through my VPN. And let's just see if we've still got connectivity here. Cross your fingers. Looks like we do. My computer's just going really slow, like it always does. Okay, and we do. And I'm going through my virtual private network, and one of the ways that I could tell that is to go to some website that tells me my IP. And I hate to use this one because it's so spammy, but I'll do it anyway. Okay, what is it? IPchicken.com. Okay. I was going to go to what is my IP. Okay. This is the address of my remote server. It's not the address of the internet here. So I'm going out to the internet through my VPN. And I usually try to do that, anytime I'm on unsecured Wi-Fi, because, I don't want the guy next to me to be able to see what's going on. And if you saw my Exploring Network Traffic presentation, I hope you're convinced that, if you're on an unsecured network, anyone can see what you're doing. Okay, so that was the first scenario. That was connecting a laptop through an untrusted network, the internet, to our remote office. Okay, so our next examples, instead of using a TAP device, which is a virtual Ethernet device, we're going to use a tunnel device, which is a virtual IP device. So we're going to be using routing instead of bridging. And so we're going to be looking at routing tables a lot. So I just want to I'm sure most of y'all already know this, but I kind of want to explain how IP addresses work. So right here, I've got an IP address. This is the form we're probably all most familiar with. 10.2.0.3. They call this dotted quad. And these are all base 10 numbers. Each one of these numbers is an 8-bit number. That's why the max that you can have is 255, because 8 bits can only express 256 combinations, 0 to 255. We can also express this address in hexadecimal. So, 10 decimal and hexadecimal is 0A, 2 is 02, 00, blah, blah, blah. And so, of course, you could also express that in binary, and here's what it is. So our network masks are usually something like 255.255.0.0 or whatever. Well, what does that mean exactly? 255 we can represent as FF, but 255, that means that all the ones are set. So for this address, all these are ones and all these are zeros. And what you can do is you can combine this mask with this address, and it says which part of the address is the network portion and which part is the host portion. So here's our address up here. Here's our net mask. I mean, your computer does all these bitwise, or not it does a bitwise OR. Yeah, bitwise OR, and it can get the network and it can get the host. So in this case, we've got a 255.255.255.0 net mask combined with our address gives us this is the network and this is the host. You know, you might say, well, couldn't we have these two be zeros? Couldn't we, cut it in the middle here? Well, you can. It just gets confusing. So usually we just cut it off on a 8-bit boundary.
I see a lot of network masks use 240 part of it.
Yeah. My brain just doesn't work on anything that, the one doesn't cut off. Yeah. So it would be like, every other decimal. It just gets confusing.
I think there's really I haven't worked out what
248 or something for 5.
Yeah. Okay, another way that we could express this is saying, okay, this is this IP address /24, and that means that the net mask is 24 bits long. That's what this is showing here. And this is important when you start looking at routing tables. Okay, so where are we? Let's look at scenario 2, where we just have an office over here, an office over here. And they're going to connect through the untrusted network. These red lines denote that it's a VPN connection. So they're going to connect through this untrusted network, and we're going to use IP routing. So let's look at how we're going to configure the router on Office A. In my virtual setup, I've got one router and one host in each of these networks. So I call this router A and this host A. And this is going to be router B and this is host B. So let me get on router A and see what's going on.